So chapter 2 is titled Integers, and integers are going to be numbers that don't have decimals. They could be positive, could be negative. That's the kind of stuff we're doing in chapter 2. The first section, so 2.1, is integers and absolute value. So integers and absolute value. And the nice part, I think that you're going to find most of this section 1 is going to be review. And I think they hit it because it's review, but where some people have it mastered, some people they find still kind of mess up on it. So we're going to hit it one more time. I'm going to start by drawing a number line. I'd encourage you to do the same. And I'm just going to take and put a 0 right about there in the middle. And what could you say is true about every single positive number on a number line? All positives are where compared to 0? Yep, to the right. So all positive numbers are going to be this way. So you have positive numbers. And if you have a larger positive number, it's going to be further on the right. Agreed? So if you wanted to on your number line, you could put in little tick marks and numbers. I'll maybe put in 1, 2, 3, 4, 5 and label the 5. But 1, 2, 3, 4, 5, those are all positive numbers. Decimals are included. 0.1 or 0.000001, is a positive number because it's going to be to the right of 0, just really, really, really disgustingly close to 0. Still good? All right. All negative numbers are going to be to the left. So over here we have negative numbers. All negative numbers are to the left. And 0 is neither positive nor negative. So neither positive. I'll be honest, I was just excited to use the neither nor you learn in English. Neither positive nor negative. So neither positive nor negative. If you wanted to, for those positives and negatives, you could say x is going to be greater than 0. And for negatives, you could say x is less than 0. Or x would be the number, But, or if you wanted to leave the x out, I suppose you could even just put in like that little hashtag thing to stand for numbers. So numbers less than 0 or numbers greater than 0. That maybe would make more sense. So. Feeling okay on those? One final thing I want to hit, and we'll move on, is I'm going to say that as you go to the right on the number line, the numbers are getting bigger. So these are getting bigger. And as you go to the left, it's getting smaller. Typically, if you add a number, so say you have a number on the number line, you're going to add something to it, you're going to move to the right. If you have a number on the number line, if you subtract something from it, you're going to move to the left. You're going to get smaller when you subtract. Now, if you start adding negatives or subtracting negatives, then that's going to kind of mess up that. But if you're adding a positive number, you go right. If you're adding a negative, you go left. Keep going? Okay. Then I want to define integers. So integers, and this will come up a little bit more when you hit algebra next year. It's all numbers without decimals. So all numbers without decimals. And sometimes they add to that or fractions. Because if you have like 1/2, do you agree that's really just a decimal? It's 0.5. Or 4/5 is 0.8. Or 1 1/2, it's 1.5. If you wanted to kind of write that out, you could say ... saying it kind of continues there, comma, -2, comma, -1, comma, 0, comma, 1, comma, 2, comma, ... or something like that. But those are going to be integers. Numbers that don't have any decimals. Positive could be negative, could be 0, and so on. Good? I have in my notes that larger numbers are farther to the right on the number line, and lesser numbers are farther to the left. Write it, or we kind of cover that with getting bigger and getting smaller up there. I feel like we covered it okay. You guys too? Okay, but you could write that if you wanted to. Larger numbers over on the right, smaller numbers on the left. All right, then we just have one last section to hit today. And it's going to be absolute value. The book has like an official definition of absolute value. I'll write it, just I feel guilty not, but I don't find it insanely helpful a lot of the time. But basically it's the distance between a number and 0 on the number line. So it's the distance between 0, and a number on the number line. Here's kind of the Falk version of the truth. It's really just you take what's inside the absolute value sign and make it positive. So take what's inside and do those two vertical lines and make it positive. And want to do a couple examples of those. So if we were to say absolute value of -4, well, we take what's inside the absolute value sign and make it positive, so we get 4. Or if I were to do absolute value of -3.5, that's going to be positive 3.5, agreed? This will mess up some people. If I say absolute value of 5, what's the absolute value of 5? It's just 5. Nice. That some people look at it as though absolute value means you switch the sign, because teachers typically give ones like these two. They put a negative in there. But it's just saying take whatever's inside there and make it positive. So if it starts out positive, you leave it positive. Fair enough? And the way you could look at this, if you're using that official definition, you don't need to write this. But if I have a -4, and maybe put in some other tick marks, if you go back to that definition of absolute value, it's how far away it is from 0. Well, -4, you'd have to go 4 to the left to get there. Do you agree it's 1, 2, 3, 4 away from 0? So that's why you get the 4. It's that distance from 0. And the reason I say that is if we were to ask this question, what's the absolute value of 0? It's 0. And this is where technically my definition is wrong, but that's pretty much what you do. But you can't take 0 and make it positive. 0 is neither positive nor negative. But if you were to say, well, where's 0 on that number line? 0 is right there. What's its distance from 0? 0. It's 0 away. So that's kind of how you do absolute value with 0. It's 0 away from 0. So 0. Now, these here... All right. One more thing I want to look at, and this is going to be something that comes up later. Say we have... maybe I should write it this way. So we'll say example, what two numbers have an absolute value of 7? So what two numbers have an absolute value of 7? And I'm guessing a lot of you just look at that and you already know the answer, right? The answer is going to be, go for it. Perfect. So the answer is going to be 7 and -7. And you can just write that if you want to. But I want to kind of show you a notation that's going to come up. What they're saying is we're looking for x. X is going to have two different values that are possible. We're saying, well, if I do the absolute value of this number, what are two numbers that have an absolute value of 7? So what could I put in there that if I do absolute value, it gives me 7? And if you think about it, well, you could do absolute value of 7, that's going to give you 7, right? And the other, you could do absolute value of -7, because that would also give you the 7. So that's how you get your two answers. Yes? I wanted to kind of show you this type of notation there, though, because that's going to come up down the road, where we'll start doing problems that you get that partway through the problem. Any questions? Here's the very last part, and it's something that you pretty much know. I'll maybe do this. Make that a little bit smaller in case you're still copying it. Opposite numbers. So opposite numbers. I'm guessing you already know this kind of intuitively in your head. The opposite of 5 is? -5. I could try to stump you. The opposite of -pi? Is pi. So you just take the number and change the sign on it, right? One will be positive, one will be negative. So that's going to be what opposite numbers are. The way the math books define it is they say, how could you apply that to a number line? 5 and -5, what's true about them? So exactly. 5 is going to be 5 to the right of 0. -5 is 5 to the left of 0. So opposite numbers are technically two numbers that are the same distance from 0. From 0. And if you want to throw an example down there, you could say 5 and -5 would be an example. Or pick any number. -7 and 7, something like that.